Here you are going to prove the trigonometric identity, the sine of 2x divided by 1 minus the cosine of 2x is equal to the cotangent of x. First, you will need to determine non-permissible values for the identity. These occur when the denominator, 1 minus the cosine of 2x, is equal to 0, or when the cotangent of x is undefined. Solve 1 minus the cosine of 2x is equal to 0 to determine some of the non-permissible values. Use the identity the cosine of 2x is equal to 1 minus 2 times sine squared x. Simplify and solve. This means the identity will not be defined when x is a multiple of pi. You also needed to determine when the cotangent of x is undefined. This also occurs when x is a multiple of pi. So the identity is only defined when x is not a multiple of pi. Now that you have determined the non-permissible values, you will begin to prove the identity. First, split the identity into left and right sides. You will only work with one side at a time. Remember, the goal is to show that the two sides are equivalent. There are a number of clues for where to start proving this identity. The input of the trigonometric functions on the left side is 2x, and the input on the right side is just x. This may mean a double angle identity will be useful. Sine, cosine, and cotangent are all used, so converting the cotangent to a sine and cosine may be useful. The left side contains a fraction, and the right side does not. This means you will probably need to cancel parts of the numerator with the denominator on the left side. The left side looks more complex, so begin there. There is an input of 2x for both sine and cosine. Use a double angle identity on each of these so the input is just an x. Use the identity the sine of 2x is equal to 2 times the sine of x times the cosine of x to convert the numerator. Next, use an identity to convert the cosine of 2x. But there are 3 different identities that use the cosine of 2x in this course. Which one should you pick? In this case, any of the 3 will work, but one may be easier to work with than the others. This is where practice and a bit of luck are helpful. Remember, the mantra for proofs is try something. If it doesn't work, go back and try something else. A clue for you is that there is only one term in the numerator and 2 terms in the denominator. Picking an identity that will reduce the denominator to 1 term will be useful. Try the third identity. This denominator simplifies to 2 times the sine of x squared. Both double angle identities used are valid for all real x, so these steps of the proof are valid for all permissible x of the identity. Cancel 2 times sine x from the numerator and the denominator. And you are left with the cosine of x divided by the sine of x. This expression won't simplify much further, so leave it for now, and look at the right side of the identity. Convert the cotangent to a sine and a cosine using the reciprocal identity. The cotangent of x is equal to the cosine of x divided by the sine of x. This identity is only valid when x is not equal to a multiple of pi. However, at the beginning of the example, you determined that multiples of pi are not permissible in the original identity, so the proof is still valid for all permissible x. If the original identity didn't have any restrictions, the proof would only be valid when x is not a multiple of pi. The 2 sides are now the same, so the proof is complete. You have